Okay, as we've seen, x equals r cosine theta, y equals r sine theta, implies polar coordinates and area increment r dr d theta, and this can be done in abstract terms, in terms of a region of the r theta plane transforming into regions of the xy plane. That's probably still a fuzzy idea. If we have a different transformation, this is clearly not the same transformation we got here. So this is a different transformation, not interpretable as polar coordinates. We're using r and theta, but the transformation is clearly much different. So as to avoid the connotation of polar coordinates, we're going to use u and v to avoid confusion, and then we're going to write the transformation in these terms. So what we have is the UV plane, and we have some region in the UV plane, some unspecified region. This will map onto some region of the XY plane. Now perhaps we know something about the region in the UV plane, in which case the transformation can be used to determine the corresponding region in the XY plane. Or perhaps we know the region in the XY plane and need to find the corresponding region in the UV plane in order to set up the integral. And we're not going to go too deeply into this picture. Simply, there's a region here that corresponds to region here, and if you have an appropriate transformation over an appropriate domain, the transformation can be inverse. We can go from here to here. And I'll mention that we have to have an appropriate domain in order for this transformation to be invertible. More generally, I'm just going to mention that if we know this region and want to find the corresponding region of the UV plane, we have to have an invertible transformation. If we know the region of the UV plane and want a region of the XY plane that we go over only once with the transformation, it also has to be invertible, and our domain has to be restricted to, in general, our domain would have to be restricted to make that possible. So I'm just going to note there are questions of domain and don't have room to write out the word invertibility, invertibleness. The question whether this thing can be inversed, and the question of one-to-one onto all that stuff beyond the scope of what we're really going to talk about in this course. Now let's be specific. Let's take this transformation and choose a domain. So we have x equals 2u cosine v, y equals 1 over 1 plus u sine v. Let's define this transformation, just to be safe, for 0 less than or equal to u less than or equal to 2. Now clearly that's not going to cause a problem. Both of these u functions are invertible, one-to-one, and so forth. And to get the cosine and sine to behave halfway decently, let's let 0 be less than or equal to v less than or equal to pi over 2. That way both the sine and the cosine will be positive, and we don't have to worry too much about the technicalities of invertibility and so forth. Now in the u versus v plane, this region is, just like the one before, a rectangle. Region doesn't have to be a rectangle, but it often will be. So if this is u and this is v, then u goes from 0 to 2, while v goes from 0 to pi over 2. And here's our rectangle of definition. Now let's assume that this rectangle has been subdivided along either x or y, and then for every one of those intervals we have an interval in the opposite direction. So we have a nice rectangular grid here. Now for simplicity of the picture, let's just assume that the point 1 pi over 3. And let's say that point occurs about halfway across here would be 1, and pi over 3 may be about here. Let's just say that, okay, we got this point 1 pi over 3. Question is, what happens in the xy plane if u changes by delta u and v by delta v? And let's complete a sentence here. Let's say starting at the point 1 pi over 3, what happens in the xy plane according to this change in u, this change in v? Well, the change in u is going to result in a change in x and a change in y, and the change in v is going to result in a change in x and a change in y. Now, first of all, let's go over here into the xy plane and see what point corresponds to 1 pi over 3 here. It's not hard to calculate. If u equals, okay, let's hold up a minute here. Having listed u first, then v, I automatically started thinking u here and v here, but I've got u here and v here, which means two things. The limits on u go from here to here, so that this should be 2, and the limits on v go from 0 to pi over 2. That should be pi over 2. This one's pretty easy to correct, but I'm going to have to go off camera and correct this. And while I'm at it, I'm also going to have to correct the coordinates of this point. The v coordinate goes first. That'll be pi over 3. The u coordinate being the second coordinate, that'll be pi over 3, 1 instead of 1 pi over 3. Okay, I think I've got my labeling corrected. That one looks like it got a little too much growth hormone, but we'll live with that. Okay, so starting at pi over 3, 1, where v is pi over 3, u is 1. Well, u is 1, so x is going to be 2u, 2 times whatever the cosine of pi over 3 is. Excuse me, I think we've got about 3 weeks of hay fever season left. Okay, the cosine of pi over 3 is 1/2, so that we're going to get 2 times 1/2, or just 1. So x is going to be 1 at this point, corresponding to this uv point, and y is 1 over 1 plus u. Well, u is 1, 1 plus u is 2, so that's 1/2. The sine of pi over 3 is the square root of 3 over 2. It's going to be 1/2 the square root of 3 over 2, which is going to be square root of 3 over 4. so that this point of the UV plane maps to this point of the XY plane. Next question is, if we move delta V in this direction and move delta U in this direction, what kind of changes do we get? Well, let's just take our delta U here and ask ourselves, what effect does delta U have on X and Y? The effect on X is determined by the derivative of X with respect to U. The effect on Y determined by the partial derivative of Y with respect to U. So that we do our partial derivatives. The U derivative of X is just 2 cosine V. The U derivative of Y is just, well, derivative 1 over 1 plus U is 1 over the quantity 1 plus U squared. So that our YU is 1 over 1 plus U squared sine V, meaning that a change of delta U from this point, a change in the U direction of delta U, or from any point